Okay, today we're going to be finding the measures of similar figures. And what we know about similar figures is that the ratio of the perimeters of each perimeter is going to be equal to the ratio of side lengths. So what that means is, if I divided 6 by 9, 6 being the matching side to, or the corresponding side to 9, I would get an answer of 0.6 repeating. If I divide 8 by 12, I would get an answer of 0.6 repeating. And this is going to happen when I divide 12 by 18 and when I divide 14 by 21. Well, if I find the perimeter of the first shape, and that is 40, and I divide it by the perimeter of the second shape, which is, I forgot what it was. Let's see, that's 33, 43, 51, which is 60. And I divide 40 by 60, I'm also going to get 0.6 repeating, because the ratio, remember that's just simply a fraction, the ratio of perimeters is equal to the ratio of side lengths. Remember, all fractions are division problems, so when I divide this and turn it into a decimal, I can easily see that they are, in fact, equal. They all come up to 0.6 repeating. Okay, when I divided 6 by 9, remember 6 being the matching side to 9, and I got this 0.6, what I discovered was my scale factor. The scale factor is the rate at which the shape is enlarged or reduced. So my scale factor is 0.6, or as a reduced fraction, 2/3. Okay, something else that I know, we've talked about perimeter being equal, the ratio of the perimeters of two similar figures is equal to the ratio of side lengths. Well, what I know about area is the ratio of the areas is equal to the scale factor squared. So let's find the scale factor of these two rectangles. What I first need to do is set them up as a fraction that I can reduce. I could go 2 over 6, or I could go 6 over 2. It doesn't matter as long as I'm using the same side, and I am, or similar, the corresponding side, and I'm writing it as a fraction. Well, I know that 6 divided by 2 is 3. And if I do the same thing for the other two sides, the corresponding side, I would put 12 over 4. And I also know that that's 3. So far we've proven that we have similar figures here because they're the same shape, they're not the same size, but their sides are equal ratios. Well, I'm talking about the area. My ratio of areas should be equal to my scale factor squared. Well, what's the area of the first rectangle? 2 times 4 is 8. What's the area of the second rectangle? 6 times 12 is 72. So I'm saying that 72 divided by 8 should equal my scale factor squared. In other words, it should equal 3 squared. Remember that 3 squared is the same thing as 3 times 3, so I'm looking for an answer of 9. 72 divided by 8 is 9. So in fact, my ratio of area is equal to my scale factor squared. Okay, here I have two figures, and so I want to know how can I use that information that I just gave you, knowing that the ratio of the perimeters of two similar figures is equal to the ratio of the side lengths of the scale factor, and that the ratio of their areas is equal to the square of the scale factor. Well, here I have two figures. I'm telling you that the larger of the two figures has a perimeter of 38 centimeters. It has an area of 50 centimeters squared, and that the scale factor, that's big to little, that's little to big, is 3 to 5. So my scale factor is little, 3, big, 5, 3 to 5, giving me the fraction 3 over 5 here. So how can I go about using that to figure out what the perimeter of the smaller shape is? I can actually use a proportion again. Because I have 3 over 5 as my first ratio, and I know that my perimeters have to be equal ratios, I can just say that 3 over 5 is equal to, well, remember the 3 represents the smaller of the figures, the 5 represents the larger of the figures. They gave me the perimeter of the larger figure, so that means the 38 needs to go on bottom for my other ratio. And I'm trying to remember that 38 is perimeter, so I can replace my numerator with an x. And by cross multiplying and dividing, I can figure out what the perimeter of the smaller shape is. So I would just say 5 times x is 5x, and that is equal to 38 times 3, which is 118. And when I do that math, I discover that the perimeter of the smaller figure is 22.8 centimeters. Okay, so now I need to figure out my area. If you remember right, they said that the area was equal to the ratio, was equal to the scale factor squared. Well, that means the very first thing I have to do is I need to take 3/5 and I need to square it. Well, when I square it, I have to square the numerator as well as the denominator. So 3 squared, which is 3 times 3, that's equal to 9. And 5 squared, which is 5 times 5, is equal to 25. So to find the area of my smaller shape, I won't be using 3/5. I'll actually be using 9 over 25 because remember, it's equal to the scale factor squared. So let's go ahead and set up that proportion. 9 over 25 is equal to, well, they gave me the area of the larger figure, and it was 50 centimeters squared. That means that my 50 needs to go on bottom because the 25 represents the larger figure, while the 9 represents the smaller figure. And now we'll replace the numerator with an x. Cross multiply, 25x is equal to 450. And when I divide, I find out that x is equal to 18 centimeters squared. And that's how you find the perimeter and the area if you know that the figures are similar and you've been given the scale factor, or you can figure out what the scale factor is.